Go ahead and get started. Today is Wednesday, February 27th, the second to last day of February, and we are continuing right along today with Eureka Math, Module 4, Lesson 15. And our learning goal is short and simple today. Today I can use pictures. We're really emphasizing our use of pictures to help us multiply fractions. It used to say unit fractions, non-unit fractions. By the end of today, you should be able to use pictures to multiply any kind of fractions, unit fractions or non-unit fractions. The directions tell us to draw a rectangular fraction model. Luckily, we're very good at drawing rectangular fraction models now to show our thinking. Then, write a multiplication sentence. With your fingers, how many things is this question asking us to do? So how many things do we need to do? 2. Yesterday on your exit ticket, it also asked you to do 2 things. Draw a model and then write a math sentence. Some of us decided only to do the first thing, draw a model. What that teaches us is we need to read the directions very carefully. If it tells us to do 2 things, please do 2 things. Okay? Let's do the first thing first. We want to find 2/3 of 3/4. So let's draw a rectangular fraction model. On our rectangular fraction model, which fraction should we show first? 2/3 or 3/4? Everyone? 3/4, because we don't know what we want to find 2/3 of until we have the picture of 3/4. So in order to do that, we're going to divide our rectangular fraction model into fourths, and we're going to shade in 3 of them. Oftentimes, we forget to do the shading part. We don't want to forget to do the shading part because that's an important part of a complete fraction model. We also don't want to forget to do the labeling, so we'll show that that's 3/4. Do we want all 3/4? No, we only want 2/3 of the 3/4. So we want to now divide it into what size units? Thirds. Good. So we're going to divide it now into thirds going this way. Now keep in mind, be careful. Even though I didn't shade anything over here, I'm extending my thirds all the way to the end. The entire rectangular fraction model is divided because that's going to help me figure out my units later. Okay? How many of those thirds do I want to shade in? 2. The fraction tells us that we have 2 of those thirds. So shade in 1 of the thirds and then the second third, 2/3. And of course label it as 2/3. Now if I look at my entire fraction model, I've divided it into what size units? How many units? 12. Good. So I know that my denominator is going to be 12ths. How many of those 12ths are doubly shaded in? 6. Okay, 6/12 we know is the same as 1/2. So the answer is 1/2. Are we done? No, because we need to write a multiplication sentence. 2/3 of 3/4. How can I write that as a multiplication sentence? Well, we know the word of means multiply. So this is 2/3 times 3/4, which is equal to 6/12, which we know was equal to 1/2. I like the way you said that. So Marth said he noticed that it's 2 multiplication sentences on top of each other. In the numerators, over here we have 2 times 3 equals 6. We know that's true, right? And in the denominator, we have 3 times 4 equals 12. Interesting. Over here, in the numerator, we have 2 times 2 equals 4. We also know that to be true. And in the denominators, we have 3 times 3 equals 9. So it's seeming like when we multiply, when we use our pictures to help us multiply, it's the same thing as multiplying the numerators and then multiplying the denominators. I'm starting to notice a pattern, but just having it be true for 2 problems doesn't mean it's always true. So let's continue our work with our pictures today and keep this in mind and see if this pattern is still true. Does that make sense? Let's keep going. When we draw our area model, we know that in order to find the denominator, we have to find out how many units there are in our entire fraction model. For this example, in order to do that, we knew that there were 7 across and 9 going down. So in order to find out that there were 63 pieces altogether, we did 9 times 7 to find the area, 9 times 7. Then we knew in order to find the numerator, which happens to be 21, we had to find out how many were doubly shaded, which is this section right here. In order to do that, we know that there's 3 going across and 7 going down. So we did 7 times 3, which is 21. Coincidentally, we can see in our numerator we have 7 times 3. 7 times 3 is 21. And to find the denominator, how many pieces there are altogether, we have to do 9 times 7. 9 times 7 equals 63. So therefore, 7/9 of 3/7 is 21 over 63. Now we can simplify that, but we're going to keep it like that for right now. Does that make sense? We already know that 3/10 times 5/9 is the same thing as 3 times 5 in the numerator over 10 times 9 in the denominator. Do we see any numbers in the numerator and the denominator that have common factors? We've learned this before, yes? Good. Geffen?
3 and 9.
3 and 9 are both divisible by?
3.
So I can divide 3 by 3 and get?
1.
I can divide 9 by 3 and get?
3.
Very good. Anything else? Brian?
5 and 10.
Are both divisible by?
5.
5. So 5 divided by 5 is?
1.
10 divided by 5 is?
2.
Here's a step I don't want you to skip. Once you've crossed things out and written the new factors, I want you to rewrite the problem. Don't just solve it, okay? Because sometimes our factors, we cross out and our factors go out into outer space. So what are our new factors? 1 times 1 in the numerator over 2 times 3. And now we know that is 1/6. I find it much easier to simplify before you multiply because the numbers are smaller. I didn't know off the top of my head that 9 divided by 5 was 18. I'm glad you guys did the math for me because I would have to write out the standard algorithm. Okay? But I did know off the top of my head that 10 divided by 5 is 2 and 9 divided by 3 is 3. So it's a lot easier for me to do it before. Does that make sense? Good.